Latest longevity guides here. August 2024. Maria Brañas, Spanish grandma, died. She lived 117 years, 168 days. She's 7th longest lived. She didn't just live long, but survived 2 global pandemics. When they checked her habits, she ate only 3 yogurts a day. Wait, don't shop yet. Not the yogurt brand she ate. To find longevity's secret, scientists used science and analyzed her body. They found that Maria had somehow completely uncoupled aging from disease. She never even got cancer. So the question is, can we all, like Maria, grow old without getting sick and still live a long, quality life? I'm Dr. Zeng Dingjing, a geriatrician. Today, I'll show you how this record-breaking woman became a human miracle. If you haven't subscribed yet, please tap that button so we can have a good new year. After that, grab your key to science and unlock a long, healthy life with me. Maria's life spanned almost the whole history of modern medicine. She was born in San Francisco in 1907 and died in Spain in 2024 at 117 years and 168 days old. She was then the world's oldest living person. She survived 2 world wars, the Spanish Civil War, and 2 global pandemics. COVID-19. Pretty incredible, right? She even caught COVID at 113, but it never turned severe, with no complications, and she fully recovered within weeks. For infected people over 90, the severe COVID rate is actually over 20%, and the death rate approaches 10%, 20 times that of people in their 50s. Because at that age, the immune system usually ages with the body. T cells drop, B cells lag, inflammation persists, so beating infections hard. But Maria's real edge was this. Her immune response was like a seasoned old soldier, precise and still efficient. Blood tests also showed her pro-inflammatory cytokines, IL-6 and TNF-alpha, at barely a third of typical seniors. That means her immune system didn't flare up or fire blindly, but could zero in on the right target. Her immune system worked properly without rage. From a clinical standpoint, that's a rare kind of immune resilience. So how did her immune system stay so stable? The medical community launched a full investigation into Maria to find out what kind of defense system she had inside. The first clue they found turned up in a very familiar place: her daily diet. What are long-lived people actually eating? The medical team found Maria ate 3 servings of plain yogurt a day. It wasn't a special brand or some expensive formula, but this seemingly ordinary habit greatly shaped her health. Whether you take in nutrients or carcinogens, it all gets absorbed through the gut. The conditions of your gut can affect your whole body. When the team analyzed her gut samples, they found her gut microbiome was almost like a young person's. What does that mean? In our gut, there is a super important good bacterium. It's called bifidobacterium. It's referred to as Bifidobacterium bifidum. In short, bifidobacterium, or just B. bifidum. Yep, that name is often seen in ads for probiotics, yogurt, or something like that. This really matters. Once bifidobacteria colonize the gut, they break down sugars and produce short-chain fatty acids, like lactic and acetic acids. These curb harmful bacteria and improve the gut flora, thereby reducing inflammation. Bifidobacteria can balance T-cell responses, so our immune system works properly. So in Maria's gut, why were there so many bifidobacteria? Scientists think it was her diet. She ate 3 cups of cultured yogurt daily. She followed a Mediterranean diet of veggies, olive oil, beans, and fish. These foods have been shown to nourish beneficial bacteria, including bifidobacteria, and reduce chronic inflammation. Clinically, we know the gut is the body's largest immune organ. About 70% of immune cells are there. And in Maria's case, this was the first time we'd seen that if the gut stays young, the immune system can stay young too. But the gut may be just the tip of the iceberg, because Maria's health far surpassed that of typical centenarians. She didn't just live long. Her condition was nothing like that of a 100-year-old. Most her age folks have 3 to 4 chronic diseases, constant meds, less mobile. But Maria's blood sugar, cholesterol, liver and kidney functions stayed at the level of a 70-year-old. Elasticity of blood flow to heart and brain was above average for her age. Even she felt it was unbelievable to be this healthy. So she went to the research team and said, "Why don't you study me? Maybe it could help others." In her last year, they launched the most comprehensive longevity decoding project. From genome, epigenome, to proteome, metabolome, they scanned her molecular makeup with multi-omics. and they really found two striking features. First, her DNA repair genes were active. By 80, most people's repair systems nearly stand still. When DNA damage builds up into mutations, metabolism slows and can lead to cancer. But in Maria's case, her genetic repair crew never retired. Second, her epigenome showed almost no common signs of aging. The epigenome is the master controller of our gene switches. Those switches start going haywire with aging, throwing immunity and metabolism off balance. But in her case, those switches stayed well ordered. To verify just how slowly time was really moving for her, scientists used DNA methylation clock to test her bioage. They found her cells were 23 years younger than her age. Her aging rate was even negative, -17.3. In science, that's almost unheard of. Her biological clock ran at just 1/3 speed. While others aged a year, she aged only 8 months. Her body truly aged so very slowly. So were her genes really that different? Answer may be opposite. Pre-Maria, scientists analyzed hundreds of centenarians' genes. Most had trump card, FOXO3A. Every one of us has this gene, but in some people's DNA, there is a mononucleotide variant. This variant can in fact be found in many centenarians, so it's also called the longevity gene. Having this variant can help cells, under stress, enter the power-saving mode, pause division, and start repair. Like when your phone is in that mode, shuts background apps so battery lasts longer. But the remarkable thing is that Maria didn't have such a trump card. In short, she didn't win the longevity lottery, yet hit the jackpot. That left the research team stunned. So, what made it possible? First, although she lacked the longevity gene variant, interestingly, Maria also had absolutely no harmful variants linked to a shorter lifespan. But the most paradigm-shifting finding was that her telomeres were extremely short. Telomeres, a cap at the end of DNA. When a cell divides, it wears down a little. Once it's worn away, the cell can no longer divide. So in theory, short telomeres age. Telomeres are like a cell's self-destruct countdown. When time's up, DNA breaks down, cells die, bringing cancer, aging, even organ failure. This is the theory scientists have firmly believed in for years. Longer telomeres mean longer life. In fact, many longevity researchers have tried to lengthen telomeres to stop them from wearing down. But Maria stunned everyone again. Her telomeres were under 8 kilobytes, half the typical centenarian's length. Among all the study subjects, hers were the shortest. Yet even with extremely short telomeres, she stayed healthy and cancer-free. To explain this, scientists said too long telomeres might be risky. If cells live too long, mutations have more time to occur, and cancer cells may gain immortality. This hypothesis also matched what researchers observed in Maria. So the team began to wonder if short telomeres are the body's own natural built-in anti-cancer strategy. From a medical standpoint, this is a classic biological compromise, a trade-off. Her body chose to sacrifice some regenerative capacity for a stronger defense against cancer. This isn't a byproduct of longevity, but a firewall built by her own body. But it's a new hypothesis and may be overturned or suggest directions. If you want to follow the latest in longevity research, subscribe to our channel. Lead researcher Dr. Manel Esteller reached an important conclusion. Longevity is about 50% genes and 50% lifestyle. Maria did have a good hand. Those genes that help repair, fight inflammation, and maintain balance made her more resilient as she aged. But what truly got her to 117 wasn't just good luck. She earned it herself with a lifetime of quietly living in sync with her body's natural rhythm. So what can ordinary people learn from her? Here are 3 practical takeaways for your reference. Microbiome first. Foods that help bifidobacteria grow don't just include yogurt. Kombucha, kimchi, sauerkraut, and miso contain them too. Anti-inflammatory. She followed a Mediterranean diet. No cigs/booze. Routine, deep sleep, slow living. These ordinary habits kept her immune system and metabolism in balance. Third, stay mentally and socially active. Even in old age, she read, typed, and chatted with family. Mental health isn't just about emotions. It's also key to stable brain and immune function. From a doctor's point of view, we can't copy her genes, but we absolutely can copy her physiological state. Maria's story shows us once again that if you want to live long, the key isn't how much cutting-edge tech you use. It's about repeating healthy habits day after day to build an ideal retirement life of your own. There's still much more to learn about longevity. What do you want to know? A. Which gut microbes can affect my lifespan? Or B, longevity gene FOXO3A. Do I have it? How can I tell whether I do? Comment below now. If you want to know more about new medical advances, keep watching our show. And don't forget to subscribe. Join Team Health. Let's stay healthy together.